Looking at the third question from 2009, good 1D array problem. So we've got here this charging table. Now remember, this is just a sample, so our code needs to be able to work for any type of charging table. We do know it's going to be a 24-hour, so a 24 entry array, but we don't know what the actual costs are. This is just a sample array table. And what's going to happen is they're going to give us a start time. So that's where we're going to enter the table at, and a charge time. That could be 1 hour, 5 hours, could be a million hours. The only thing we know is that it's guaranteed to be a positive in. That's important to remember. As we write this code, we might get caught looking at this example thinking, oh, as long as I can handle 30 hours, I'm okay. Well, no, your code needs to be able to handle a million hours. Like they only told us it's positive, so we don't know anything else about it. And the reason that's going to be important is say example, you enter the table at hour 22, you need to charge 7 hours. Well, pretty easy to see. If I enter this table at 22, I'm going to charge 1 hour for a cost of 80. Second hour is going to cost me 60. There is no third hour at that point. So just like a 24-hour clock, it would have to roll back to 0 and pick back up there, go 0, 1, 2, 3, 4, and pick up those 5 charges. So our code's going to need to be able to walk through the table like that. After 23, it's going to have to step back to 0. Obviously, we could accomplish this with an if statement or various other things too. I'm going to show you how we can use a modulus. I think that's probably the most efficient way to handle this. And then in part B, pretty easy minimum method to write. Just hypothetically, here's a charge time. So they've removed the start hour, and we need to find what would be the optimal start hour then to get the minimum cost. And we know there's 24 possibilities, so as long as we write a loop that could check all 24, we'll be fine. And this is another case where we have to use our method from part A if we want to receive full credit. So we should not try to recreate any code in part B that we've already written in part A. Okay, so the battery charger. In part A, again, you got a start hour and a charge time. This is a basic total method. So right now we have a total of 0. We haven't charged anything yet. And then later we'll figure out what our cost is. Remember, each hour potentially has a different cost. So for each hour we have to access the table. And what we might want to do here is, maybe we want to write a for loop, maybe we want to write a while loop. I can see a lot of ways to do it. So we could just keep rolling that charge time back 1 each time the loop runs until we reach 0. We could create other variables here, but this does kind of tend to mesh nicely with a while loop. So I'll just say, as long as this charge time is positive, meaning there's more hours to charge, I'll keep charging. And then at the end of my loop, I'm just going to roll back that charge time. And as I roll back the charge time, I'm going to roll up the start hour, and that way I'll enter the table at a different value. Now, like we saw though, if we start doing that with start hour, we're going to go from 22 to 23 to 24 potentially, depending where we enter the table and how much charge time we have. So when I access this array, I'm just going to use a little modulus trick. This array is called rate table. Okay, so that's where we're going to get the cost from. So my total variable is going to increment each time by the rate table being accessed at the start hour. And I'm just going to throw a modulus 24 on that, and that's going to prevent it from ever exceeding 23, right? So as soon as that hits 24, it rolls back to 0. If it hits 25, it rolls back to 1, 26 would roll back to 2, and so on. If we made it all the way up to 48, that would roll back to 0. 49 would roll back to 1, and so on. It's a great trick. Anytime you're working with time, especially, because with hours, you might have base 12, base 24. With minutes, you might see base 60. Days of the week, you might see base 7. So anytime you're working with number bases that are different than 10, using a little modulus is a great way to avoid, to cause like a rollover correction. So we're going to use get charging cost in part B, so we probably want to make sure it's working in part A, and it looks like everything's perfect. Now again, there's a lot of other ways you can handle this if that modulus is bothering you. I'm sure you could figure out a way to correct this with an if, so just add like an extra if after the start hour. So if start hour equals or exceeds 24, start hour minus equals 24 would be like a good way to correct that, and then it would correct itself each time. You don't have to use a while loop. I just thought it was easy since, we didn't really need to write like an initializing expression, but you could write a for loop here, maybe make a copy of the charge time or whatever. All right, so now get charge start time. Remember, we're looking for a minimum. So if we want to track by hour, we can. So we could say like, best charge hour equals 0. I have no reason to think that it's actually 0, but I have to start somewhere. And then when I'm done, I'll go ahead and return that charge hour. Now in the middle, what I want to do is I want to loop and give every other hour a chance. So let's call it hour. Let's start it at 1. Let's let it reach 23. Okay. And make sure you include 23 as a possibility. And then we'll increment it by 1 each time. What we're going to do in the middle is we're going to give every hour a chance to beat best charge hour. And the way we can settle this little contest is by calling get charging cost. So if I were to call get charging cost, and to use get charging cost, you have to feed it 2 pieces of information. Right? This is that idea that the AP is so big on, method and control structures. Can you call a method? Can you satisfy its arguments? Do you understand its return? So I need to give it a start hour and a charge time. The start hour for me is being produced by the loop. The charge time has been handed to me as an argument local to this method. Okay. If this comes out to be smaller than, I'm going to call that method again, but instead of giving it the same start hour, I'm going to give it the start hour that I think is the best. I have no reason to think that 0 is the best, but I'm just giving everybody a chance to win this contest, if you want to call it that. Okay? So that's a pretty big if statement. Obviously you could break this down into like a little bit, do like a couple different ints or something. Bottom line is if that one on the left wins, that means that my best charge hour was wrong, and I should reinitialize it with, or reassign it with this hour that came to me from the loop. So I'm giving every hour a chance to be labeled as the best, and I'm confident that at the end of this, I'll be left with the best charge hour, regardless of the circumstances. They said in case of a tie, you could return either hour. That's why you might see like 23 or 0. So it would just depend on how you wrote your code and how you handled ties and where you started at, how you progressed through the hours, things like that. But they're saying it's insignificant, so don't worry about it. And you could put in some more test cases, maybe even try something for like 1,000 hours or something. But yeah, this looks fine. It's handling the rollovers. And again, we're relying on that method from part A to really do most of the work here. Okay, and we were just setting up the different cases. All right, so very good problem. Very likely your first question on your test this year will look something like this. Okay, we're told that it's going to have a 1D array or an array list. We know they're going to emphasize methods and control structures. So that means, you can expect to be calling local methods, satisfying their parameters, understanding their returns, and things like that.